Welcome children, today we will see thermal physics part 2. In the previous class we saw what is heat. Heating is nothing but the process of transmission of heat. And we saw what are the units and its characteristics. Now we are going to see what is the effect of heat energy. The effect of heat energy is nothing but when you heat a substance, automatically the temperature of the substance will rise. This we all know. For example, when we are boiling water, the temperature of the water rises. Next, the second effect is it changes from solid to liquid and liquid changes to gas. For example, when we take our ice cube and we heat it, it melts into liquid. And when that liquid is again heated, it changes into gas. Okay. The third effect is the substance expands on heating. So, usually the atoms in the solid, when you heat, starts vibrating vigorously and hence it expands. So, these are the three changes or the effects of heat energy. And now we are going to see in detail the third change, that is substance expand on heating. So, expansion of substance. Any substance, when it is heated, there is a change in the dimension due to the rise in temperature, which is called as thermal expansion. So, change in dimension due to rise in temperature is called as thermal expansion, and this takes place in solids, liquids and gases. So, now we are going to see in detail the expansion of solid. When heat energy is supplied to solid, the atoms gain energy and they start vibrating vigorously. Due to this vibration, you have three types of expansion. The first expansion is called as linear expansion, second one is called as superficial expansion, and third expansion is called cubical expansion. Now we will see these three in detail. What is linear expansion? So, linear expansion is nothing but when a body is heated or cooled, the length of the body changes due to its temperature. That is, there will be an increase in the length of the body, which is called as linear expansion. What is coefficient of linear expansion? Coefficient of linear expansion is nothing but the ratio of the increase in length of the body per degree rise in temperature to its unit length is called as coefficient of linear expansion. Now, we are going to see the relation with an equation, that is delta L by L0 is equal to alpha L into delta T. So, delta L is nothing but the change in the length, that is the final length minus the initial length, to the L0 is nothing but the original length is equal to alpha L is nothing but the coefficient of linear expansion into difference in temperature, which is represented by delta T. Now, I am sure you are clear about linear expansion. Now, we will see what is superficial expansion. Superficial expansion is nothing but the increase in the area of solid due to the rise in temperature, which is called as superficial expansion. This superficial expansion is, we can also say the coefficient of superficial expansion is nothing but it is defined as the ratio of increase in the area of body per degree rise in temperature to its unit area. This is also represented by an equation delta A by delta 0 is equal to alpha A into delta Z. Here delta A is equal to the area, that is the final area minus the initial area by original area is equal to alpha A. Alpha A is nothing but it is the coefficient of superficial expansion into change in temperature delta T. Next we will see what is cubical expansion. This is nothing but the increase in the volume due to the rise in temperature. Here also we can say the coefficient of cubical expansion is nothing but the ratio of the increase in volume of body per degree rise in temperature to its unit volume. This is represented by the equation delta V by V0 is equal to alpha V into delta T. Here delta V is the difference in the volume, that is final volume minus initial volume by original volume is equal to alpha V, that is the coefficient of the cubical expansion into change in temperature. Now we saw the expansion of the solid. Now we are going to see the expansion of liquid and gas. Here the atoms, when they gain energy due to increase in temperature, they are forced apart. So we get two different types of expansion. One is real expansion, another one is apparent expansion. What is real expansion? If a liquid is directly heated without a container, there will be a true rise in the volume per degree rise in temperature. So this is called as real expansion, and the coefficient of real expansion is nothing but it is the true rise in volume per degree rise in temperature to its unit volume. Then what is apparent expansion? Apparent expansion is nothing but when you keep the liquid in a container and you start boiling, first the container heats and then the liquid heats. So apparent rise in the volume is called as apparent expansion. That is, first the container is heated, then the liquid is heated. So there is a difference. That is not the true rise in the volume of the liquid. Here coefficient of apparent expansion is nothing but apparent rise in volume per degree rise in temperature to its unit volume. Here the unit is Kelvin minus 1 and here also the unit is Kelvin minus 1. Now there is an experiment to measure the real and the apparent expansion of a liquid. For this, you take a round bottom flask which is fitted and you take the liquid in the round bottom flask. Now it is being closed by a one holed rubber cork and you insert a now you insert one tube. Now first you are going to start heating the round bottom flask. First there will be a when you heat, the container will start heating and the level of the water first is marked as L1. After you start heating, the water, because the container is only being heated, its level will drop down. So this is marked as L2. Then again you start heating and now what happens? After the container is heated, the water is also heated and it rises. This is marked as L3. So, the difference between the levels L1 and L3 is called as apparent expansion and the difference between the levels L2 and L1 is called as real expansion. The real expansion is always more than the apparent expansion. Okay, I think now we are clear with the expansion of liquids. Now we are going to see the fundamental laws of gases. There are three important laws. One is Boyle's law, Charles' law and Avogadro law. All these connect the relationship between pressure, volume and temperature. First we are going to see what is Boyle's law. Boyle's law is nothing but when the temperature of a gas is kept constant, the volume of a fixed mass of gas is inversely proportional to its volume at constant temperature. In other words, we can say for an invariable mass of a perfect gas at constant temperature, the product of its pressure and volume is constant. Next we are going to see what is Charles' law. The other name of Charles' law is known as law of volume. Here, when the pressure is kept constant, the volume of the gas is directly proportional to the temperature. So V is directly proportional to T or V by T is equal to constant. Next we are going to see what is Avogadro law. At constant pressure and temperature, the volume of a gas is directly proportional to the number of atoms or molecules present in it. That is, volume is directly proportional to the number of molecules present in it. The Avogadro number Na is represented as 6.023 into 10 to the power of 23 moles. Okay, I think now you are clear with Boyle's law, Charles' law and Avogadro law.